So the first thing to design is the drive system. The simplest is to simply replace the existing diesel motor with an electric motor and keep the existing transmission. It and while it has the advantage of simplicity, you end up with a whole lot of gears that you're not going to use, and those gearboxes, transfer case and so on have significant drag. So it's not particularly efficient, and efficiency is important with electric vehicles because you have limited battery capacity and you want to be able to go as far as possible with whatever battery capacity you have. The second option is to keep the transfer case and drive that directly by the electric motor. To get the gears right for that, you'd probably have to drive the transfer case in low range all the time, which means that you're in four-wheel drive all the time, but it doesn't have a differential, so it would it wouldn't work because you need a differential between the front and rear axle. Could consider a transfer case from another vehicle that has a differential, like a Range Rover or something, and that's a possibility. Another option with this same layout is to get the motor and differential from a Tesla. The Teslas have front and rear, the four-wheel drive Teslas have front and rear wheel drive with two motors, so each of those motors goes through a differential. And they're much more powerful than we'd need for the Rocky. So one motor could drive both the front and rear axle, but again, the gear ratio isn't quite right. So we'd have to look at whether it's possible to modify the differential or the gear ratio in the Tesla to give it the right gear ratio for to use in this configuration in the Rocky, and that's something we're considering. The fourth configuration is to have two separate motors, one driving the front, one driving the rear, which may be possible, but depends on how complex it is to mount and control two motors in the vehicle. So they're the sort of four options we're considering. We're most likely to go with the Tesla arrangement in the middle, driving both the front and rear axles through a differential. But it does depend on whether we can organise the change in gear ratio within the Tesla transmission. So in the next video, I'll be looking at what resolution we get for our mechanical drive system, whether we do adapt a existing Tesla motor and differential, or whether we go for some other arrangement. So that'll be what I talk about next, and looking at how to actually fit it into the car and get it all to work. Some of the calculations that we've been looking at to get an idea about the proper or the best gear ratios we need for the Daihatsu Rocky conversion. So, and the ones I've highlighted in yellow are the ones of most interest to us. So this top one here, this is looking at the Rocky. So our Daihatsu Rocky is a naturally aspirated diesel. So looking at it in high range, one thing we need to consider is the Wheel size, so these are 215/75s. That's the diameter of the wheels, and then we've got the ratio of the gearboxes and transfer case differential and the actual gear ratios and so on. Actually, that's that one there that I'm interested in, not that one. So I'm comparing the Rocky in fifth gear high range, Rocky in first gear high range, Rocky with the rear Tesla Model 3 transmission, and the Rocky with the modified Tesla transmission. So if we look at, so the Rocky in fifth gear has a speed of up to about 125 kilometre an hour at its peak revs of about 3,500 RPM. In first gear, it's about 29 kilometres an hour. With the Tesla motor and transmission, if we have the transmission unmodified, it has a top speed of 52 kilometres an hour, bearing in mind that the Tesla motor will go up to 12,000 RPM, so that 52 kilometres an hour is at about 12,000 RPM, and that seemed a bit too slow. So modifying it, changing the ratio by about half, gives us a speed of up to about 108 kilometres an hour, a top speed at 12,000 RPM, which seems fairly realistic for the Daihatsu Rocky, given that it's not, it's a fairly basic four-wheel drive, doesn't have terribly good road handling and so on. So I don't know that I'd want to go much over 100. So that seems to be a fairly reasonable ratio for the Rocky. So we'd have to modify the Tesla transfer case to give us that ratio. The other thing to consider is how much torque we have, bearing in mind that we want to be able to tow our trailer off-road and so on. So these are the calculations down here. So the turbo diesel in the Rocky has got a torque of about 245 Newton meters at 2000 RPM. But it's at a fairly narrow range. It only happens around 2000 and it drops down quite quickly on either side of that. If we look at the graph here for the Tesla motor, they hold their torque is pretty constant at somewhere around 500 Newton meters for the first 5,000 RPM, and then it drops off once you start getting close to 12,000 RPM. So at low speeds, it's very high torque, and then it drops off. So if we convert that to what is the torque at the wheels in different gear combinations. So in fifth gear, it's about 990, say 1,000 Newton meters at the wheel. In first gear, it's about 4,000, and in low range it'll be probably double that. So about 8,000 Newton meters at its maximum torque. So that's the maximum at 2000 RPM, and it would be less on either side of that. The Tesla motor and the Tesla differential, if we don't modify it, it's 16,000, so much higher torque, but also much slower speed. It only goes up to 50. If we modify the torque, modify the ratio in the Tesla gearbox, then the torque is about 8,000. So that's very similar to the torque that would be getting in the Rocky at its peak speed, about 2000 RPM, in low range four-wheel drive. So that's quite a reasonable outcome, and would be quite acceptable for towing a trailer and going off-road and so on. So this Tesla modified differential seems to be pretty well suited to what we're looking for.